Hello, this is our first set of notes on transformations of functions, and this video focuses on transformations of absolute value functions. So to start out, we're just going to review what absolute value is before we move into what an absolute value function is. So absolute value is the distance from zero, and it always makes a number positive. So if you want to pause the video really quick and answer the following, see if you can do them on your own, and then we'll go through them here. So absolute value of 4, most of you guys feel comfortable here, is 4. Absolute value of negative 6 would be 6. It's 6 spaces from 0. Absolute value of negative 4 plus 1 would be the same as absolute value of negative 3, so that would be 3. Negative absolute, negative absolute value of 1. So that negative comes after we take the absolute value. So I would say the absolute value of 1 is 1. And then that negative would make it a negative 1. Absolute value of 2 plus 7, same as 2 plus 7, 9. Absolute value of negative 1 minus 6 becomes 1 minus 6, which is negative 5. Alright, so let's look at the general form for an absolute value equation. So the parent function's on the left. It looks like y is equal to the absolute value of x. So you can see nothing's added, nothing's subtracted, nothing's multiplied out front. It is just plain absolute value of x. That's our parent function. That hasn't had any transformations done to it. It's what we compare everything to. On the other hand, if I look at the one on the right, it's a little bit longer. It says y is equal to the absolute value of x minus h plus k. You'll notice I added in an h and a k. So if you think back to parabolas and quadratics, we had an h and a k there too. It works the same way here. So that h inside the absolute value bars will shift our graph left or right, and it lies. And then the k will shift our graph up and down, and it's honest. So we still have an axis of symmetry. It's the line x equals h, so it's the same as whatever h is in your equation, which divides the graph in half. So there's symmetry here. So just like a parabola, an absolute value graph has symmetry. The axis of symmetry also touches the vertex because it goes through it. The vertex is the point on the axis of symmetry xy, often done as hk, just like we used to write with parabolas. Okay, so something else we need to remember is that our graphs can also get flipped or reflected depending on our a value. So remember, if a is greater than, and actually that should be 0. So if a is greater than 0, so it's positive, it opens up, and if a is less than 0, it opens down. So let's just do some examples here. The first one is actually our parent function, so it says f of x is equal to the absolute value of x. This hasn't been shifted at all left or right, so my vertex is going to be at 0, 0. My axis of symmetry is also x is equal to 0. So whatever your x value is in your vertex is also your axis of symmetry. They're the same. So let's just make a table to start. You guys are going to see there's a pattern with these graphs. It makes it easier. So I know vertex is at 0, 0. Let's just plug in x as 1. Well, absolute value of 1 is 1. 2 is 2. Let's do a negative 1. Well, that's 1. Negative 2 is 2. So I just picked some x values, plugged them into my equation, and got some y values. So let's graph those. So I'm just plotting the points in my table. So you can see it makes a V shape. There's definitely symmetry. Sorry, mine's a little off there. My axis of symmetry here would be x is 0. So it's reflected right over that point there. So absolute value graphs always make that V shape. This one opens up. They can also open down. All right, g of x is equal to the absolute value of x plus 2. So if I remember back to what we talked about a couple slides ago, whatever is inside the absolute value bar shifts it left or right. Well, nothing's added or subtracted, so this is going to stay 0. This 2 here is going to shift it up 2. That k value there is honest. So then remember, my axis of symmetry is just the x value from the vertex, so it still is going through 0. So let's make our table, and then we'll write down what's happened to it. So I know I'm at 0, 2. Let's plug in 1, I get 3. 2, I get 4. go to the other side of my axis of symmetry. So -1 gives me 3, -2 gives me 4. If you guys want to slow down and try to make the tables on your own, that's also good practice. So I'm at 0, 2, 1, 3, 2, 4. At this point, some of you guys are probably realizing once you know where the axis of symmetry is, you can just figure out half the points and then reflect them over. So again, there's my V shape. If I look back, so if you look back at the graph we just did of the parent function and compare it, you can see that this graph has been shifted up 2. So the transformation is that it's shifted up 2. And I expected that to happen because of the +2 in my equation there. Alright, so g of x equals negative absolute value of x. I don't have anything added or subtracted inside my absolute value bars, so it's going to stay 0 for my x value there of my vertex, and actually nothing's added or subtracted outside it, so my vertex is at 0, 0. Axis of symmetry is at 0. So at this point, I just know that there's a negative there that's got to do something. If we think back to parabolas with negatives, they used to make our graph open down. The same thing should happen here. So vertex is at 0, 0. I'm going to pick a couple x values to the right. So if I plug in 1, absolute value of 1 is 1. But then I have to multiply it by the negative. So if I graph the ones I just have there, and now if I keep in mind my axis of symmetry, oops, that's way off. Hopefully you can make yours a little straighter. But my axis of symmetry is going through x is 0. If I remember that there's symmetry here, that's why it's called the axis of symmetry, I can actually reflect those points over. So I could keep the table going, or I can reflect those points over and then finish my graph that way. So what I noticed here is the only thing that's different is my graph opens down. And that is because of the negative in front of the absolute value bars. So anytime there's a negative, it's going to flip that graph over and it's going to make it open down. Okay, this example says g of x is equal to 2 times the absolute value of x minus 4. So I'm going to start with the vertex again. Nothing added or subtracted in here, so it's still going to be 0, but it is shifted down 4 there. Axis of symmetry is going to be x is equal to 0, so it's still being reflected right along my y-axis actually. Let's go ahead and pick some x values. So vertex is at 0, negative 4. Let's plug in 1. Absolute value of 1 is 1. So then I would have 2 times 1 minus 4. So 2 minus 4 is negative 2. Plug in 2. That would give me 2 times 2 minus 4, which is 4 minus 4, which is 0. So I'm going to plot those couple. So I'm at 0, negative 4, 1, negative 2, and 2, 0. And then I know I can reflect those over. And I can see my 5 points there. Draw my lines in. Again, hopefully yours are straighter. And now let's reflect on what happened. So the minus 4 here, some of you maybe already were thinking about this, that minus 4 there, shifted our graph down. The whole entire graph got shifted down. So it shifted down 4. And then we also need to deal with that 2 out front. So if we think about the fact that there's a 2 there, I'm thinking that this graph looks skinnier. So what that tells me is that this graph is narrower, or you could say skinnier, and that's because the a value, which is that 2 out front, is greater than 1. So same thing happened with parabolas. If that a value is greater than 1, like 2 or 3 or 5 or 10 or 100, it makes your graph skinnier. Okay, g of x here is equal to x plus 1 and then plus 5. So the plus 1 in here, it lies. It shifts it left or right, so in this case the vertex would be at negative 1. This plus 5 is honest. Axis of symmetry would also be at negative 1 then. So my axis of symmetry is going through x is equal to negative 1. I'm going to make a table. Again, you could make a table for a ton of values in this graph. You can make a table for half the values and then use symmetry to reflect it, whatever works for you. So I know negative 1, 5 is a point. I'm going to go to the right and do 0. That would give me 0 plus 1 plus 5. So that's 1 plus 5 is 6. If I plug in 1, I would get out 7. So negative 1, 5. And then I had 0, 6, and 1, 7. Now I'm going to use some symmetry, reflect it, and then try to draw your line straighter than me. Again, there's that nice V shape. It's got symmetry. It has shifted left. 1. That's because of the plus 1 in the absolute value bars, and up 5, and that's because of the plus 5 outside of it. All right, last example. So if you just want to take a second, just look at this. Ask yourself if you can kind of predict what's going to happen. We have 3 numbers. We have a 0.5 out front. We have a plus 1 inside the absolute value bars, and we have a plus 5 outside of it. Hopefully by now you're recognizing that this plus 1 shifts it left or right, and it lies. So that's going to be a negative 1. The plus 5 outside of the end by itself is honest. It shifts it up or down. And then if you're not sure what the 0.5 will do, we'll see that in a second. Axis of symmetry is negative 1 again. So I can see I'm going right down there. So I already know it for sure should shift left 1 and up 5. And then I got to figure out what that 0.5 in front does. Let's pick some points. Vertex is at negative 1, 5. I'm going to do 0 again, so that would be 0.5 times 0 plus 1 plus 5. Well, 0 plus 1 is 1, so that gives me 0.5 plus 5. That gives me 5.5. Let's do 1. Gives me 0.5 times the absolute value of 2 plus 5. That gives me 1 plus 5, which is 6. So I'm going to be at negative 1, 5. 0, 5.5, I'm going to estimate that, and then 1, 6. Reflect that over. And I can see that V shape coming along. So the consensus I can draw is this graph is wider. So I'm going to add that in there in my transformation. And that's because of that 0.5 out front. So if I think back to parabolas again, if a is less than 1, so it's a decimal or a fraction, I guess I shouldn't say that because it could be a decimal like 1.5, which wouldn't be the case. But a has to be less than 1. Then it makes it wider. So it could be 1/5, it could be 1/100th, it could be 0.9, but it has to be less than 1. All right, so just to summarize, if we have an equation, a absolute value of x minus h plus k, a has the power to open the graph up or down, plus it can make it wider or narrower depending on what a is. H here shifts your graph left or right and it lies, and k shifts it up or down and it's honest. Thanks for watching.